All right, so hopefully you were able to check your answers for examples 2, 3, and 5. And if you've had any questions, please, by all means, let me know. I want to make sure that we're, solid on some of this transformation stuff. So we're going to do 6 and 7 together, and then we're going to finish up with this last piece. Okay, that's where we'll end, and then I'll give you, some practice problems. So looking at example 6, we have the y equals, or f of x equals 4x squared. So we are going to figure out what kind of transformation is happening here. Okay, and I think the best thing to do, start where we always start. So do your a, b, and c. So a is 4, b is 0, and c is 0. I think you guys have gotten into a pattern now where you recognize that when b is 0, your axis of symmetry is 0. And then when we plug that back in to find our vertex will be at 0 and whatever's left in the function, which happens to be 0, 0. So vertex is at 0, 0. And you can see the graph is blank here, so I wanted to give us some space to move this as we needed to. So I'm going to have you put the x-axis right there, and I'm going to have you put the y-axis right down the middle. We didn't need a huge coordinate plane for this. So but before we do any more graphing, I want to make sure I'm doing my parent function so you can see how they compare. So my parent function is going to be the y equals x squared. This is still going to be 1, 1, 1, 2, 3, 4. We're still going to do our points, and I messed that one up. Let's fix that real quick. And it should still be symmetrical. So I want you guys to kind of see how that's changing. That's something in the last video that I did not do, and I want you to be able to see that. So this is what our parent function looks like. The purple one is going to be our new function. So it has the same vertex. Okay, so that is going to be the same, which means we're going to use the same 5 points that we normally use. Okay, so I know 0 is also 0. Okay, so now I'm going to plug in my -2. -2 squared is a positive 4. 4 times 4 is 16. Wow, that jumped up really fast. So now -1. -1 squared is just 1. That gives me 4. And it should still be symmetrical. So this will be 4 as well, and 16. So my axis of symmetry is in here. I should have put that in, so I'm going to put that in now. And I'm going to put in my points that I can plot for this one. So for 1, it's going to be 1 and then 4. So 1, 2, 3, 4. Same on this side for -1. And then let's see if we can graph the 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's awesome. So it's going to be the same on this side as well. And then we're going to graph this into the best U shape that we can without it becoming a V. Okay, and this is the one that we were given. So if you look, the shape has changed pretty drastically. It's being pulled up. So when we answer this question, how does the graph differ from the parent function? When we have something that looks like this in front of our x value, this 4 in front, okay, when it's an integer like that, it's going to vertically stretch it, so it's pulling it up almost like you're stretching a rubber band. So it's going to get taller and thinner. Okay, so when it looks like this, it's going to look taller and thinner. So if you want to write something to help you remember that, so taller and thinner when you've got that integer in there. So when we jump down to example 7, I want you to see how they compare. We're going to make the same parent function with the same graph. So I'm going to roll down here real quick. I'm going to make my x-axis. I'm going to make my y-axis. Okay. And just like we did in the last problem, we're going to start with our ABCs. So A, B, and C, 1/4, 0, and 0. So far, it's pretty similar. Our axis of symmetry is still going to be in this middle here. So it's going to be the same. Our vertex is still going to be the same because it's that zero with the axis of symmetry. And again, I'm going to put in my parent function real quick so we can kind of see 1, 2, 3, 4. We can see and compare. Okay, so that's my parent function, y equals x squared. My purple is going to be my new function, so they have the same vertex. So now I'm going to use some points to see where we're at with this particular one. So I'm going to use these points, the -2 to +2, and kind of see what happens. I know 0, it's an output of 0. So if I have an input of -2, -2 squared is a +4. So 1/4 times a +4, you should get a +1. Okay, so if you remember, -1 squared is just a 1. This would give me a 1/4. Now we're getting some fractions in here. And remember, it should be symmetrical. So this should be 1/4 and this should be 1. So if I'm looking at just those 5, if I want to go to -2, +1, it's hard to graph fractions, but you need to just do your best when you do have them. But we can go out more. So for example, if I wanted to plug in 4 and -4, and you'll see why in a second why I chose those. So 4 squared is 16 times 1/4, that gives me a nice pretty number of 4. And -4 should do the same thing. -4 squared is 16 times your 1/4 also gives me 4. So I did a multiple that could be divided by 4 because of that fraction. So if I go to -4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It sounds like we're making some dance moves. Okay. And it's not a super obvious change, but if you compare the difference between the top one in example 6 and the bottom one in 7, the change you can see is pretty comparable. So how does this graph differ from your parent function? This one is what they call a vertical compression. So basically you're smushing it down, you're smashing it, okay? So it shrinks or flattens. I think flattens is a good way to describe it. You're pushing it down compared to the pulling and the stretching of this one, how it's pulling up and smashing it in. Down here, you're pushing it down. Oops, sorry. You're pushing it down so it's spreading out, kind of like when you smush dough or, you know, smash something against a flat surface. So that's what that one's going to look like. All right. So the last thing I want to talk about real quick is the transformation of these equations, your general form and order. We're going to use this a little bit when we hit graphing again. So what you'll have is you have y equals, you have an a, which is the same a that we always use. The b is not the same, so don't get confused. So we've got a times bx minus h squared, and then we have a plus k. So the h and k, this is standard for vertex form. Like this is what vertex form looks like, and this is what our transformations will follow. So you don't always have to have a long trinomial. So here, your a is going to be your reflect x, okay, is going to be your reflect x. Your b will be a reflection over y, which we don't talk about a lot with quadratics because it's symmetrical over the y-axis. And then your h is your shift left and right. And your K is your shift up and down. Okay, so hopefully what you saw with the shifting left and right in the examples, it's the opposite of what the sign is in there. So this is the standard, the minus will be in there all the time. And your vertical compression and your stretch, I'm sorry, I lost my train of thought, will be with this A in here, I believe. It's the A with the A and the B. It all goes in here together. So it'll happen in those pieces. But we're not going to have too much going on with B. So B is not something you really need to be concerned about. You need to really be focused on what this A is doing, because A is going to be is in our trinomials, it's in our graphing, it's all that. So what I need you to do for extra practice is I need you to do this 1 through 4. Oops, sorry. Your 1 through 4 right here. Okay. Graph the equations and state your domain and range. And then I'm also going to have you do this 1 and 2, 3 and 4, and this last piece right here, the 1, 2, and 3, identifying your vertex. Okay. So for your graphing pieces, make sure that you're doing an XY table. Okay. And you're identifying your domain and your ranges, because that's a big thing that we have to keep practicing. So doing your XY table, I'll write that a little neater, your XY table and your domain and ranges for these. So your X and Y, and then your domain and ranges. We're going to get a lot of practice with roots coming up, so don't worry too much about the root thing right now. Make sure you are able to find those domain and ranges and do your XY tables. That's the bare minimum I need you to be able to practice doing right now, okay? If you need to rewatch this, go for it. If you have any questions, feel free to email me or send me a remind message.